Now we are going to see Mason's gain formula. Actually, in block diagram reduction, we are always draw the reduced blocks for finding the overall transfer function. But it is a time taking process, so it is required more time to find out the overall transfer function. So in the block diagram technique, we will be reducing the block diagram by step, and after that only we will be finding the reduced overall transfer function. So in signal flow graph, once we have, after obtaining the signal flow graph, directly we can use one formula called Mason's gain formula. By that Mason's gain formula, we can find the overall transfer function of the system. This formula is stated by Mason and hence it is referred as Mason's gain formula. So now we will check what is Mason's gain formula. So overall transfer function is equal to summation of k tk into delta k divided by delta. Now delta is equal to system determinant to be calculated. So k is nothing but the number of forward path in signal flow graphs. Tk is equal to forward path gain of kth forward path. Then what is delta? Delta is equal to 1 minus sum of individual loop gains plus sum of gain product of all possible combination of two non-touching loop minus sum of gain products of all possible combination of three non-touching loops plus sum of gain products of all possible combination of four non-touching loop, etc. So what is Mason's gain formula? Overall transfer function is equal to summation of k tk into delta k divided by delta. What is delta? Delta is nothing but the system determinant. K is nothing but the number of forward paths in the signal flow graph. What is tk? Tk is nothing but the forward path gain of kth forward path. What is tk? Tk is nothing but the forward path gain of kth forward path. So what is delta? Delta is nothing but 1 minus sum of individual loop gains plus sum of gain products of all possible combination of two non-touching loops minus sum of gain products of all possible combination of three non-touching loops. Now what is delta k? Delta k is nothing but delta for that part of the graph which is not touching the kth forward path. So what is delta k? Delta k is nothing but it is delta for that part of the graph which is not touching the kth forward path. Now the steps for solving the signal flow graph. The steps for solving the signal flow graph is: step 1 is we have to identify the number of forward paths. We must first find out how many forward paths the particular signal flow graph is having. Second, we have to calculate the forward path gain tk for each forward path k. So first we have to find out the number of forward path. Second one is we have to calculate the forward path gain tk for each forward path k. Then we have to, third step is we have to identify the individual loops. How many individual loops a particular signal flow graph is having. After calculating the or identifying the individual loops, we have to calculate all individual loop gains. After that, we have to consider non-touching loops 2 at a time. So next step is we have to identify the 2 non-touching loops. Next we have to go for to find the or identifying the 3 non-touching loops at a time. Next we have to calculate delta from steps 2, 3, 4 and 5. Okay. Then after calculating delta, we have to calculate delta k as a portion of delta not touching the forward path k. These are the steps in solving the signal flow graph. Step 1 is we have to identify the number of forward path. Then we have to identify the path or we have to calculate the path gain of each forward path, then we have to identify the individual loops, then we have to calculate all individual loop gains, then we have to find out the 2 non-touching loops, then we have to find the 3 non-touching loops, then we have to calculate delta, then we have to calculate delta k. Now next we are going to see a problem. So find C of S by R of S by using Mason's gain formula. So in the question they have given to one signal flow graph. For this signal flow graph we have to find the overall transfer function or overall gain of this signal flow graph. So the first step is we have to find the number of forward path. So this is nothing but the signal flow graph. What is forward path? Forward path is nothing but from a path from input node to output node without crossing the node more than once. So this is the first forward path. The step 1 is nothing but identifying the forward path. This is the first forward path. Okay. This is the first forward path from R of S to C of S. So the gain of this forward path is nothing but we can take it as T1. Its gain is G1, G2, G3, G4. This is 1. So no problem. 1 into G1, G2, G3, G4 is nothing but G1, G2, G3, G4. So the forward path gain of forward path 1 is nothing but G1, G2, G3, G4. Now we are going to find the next forward path. This is the next forward path. This is the next forward path. So forward path means from input node we have to reach the output node. But the signal flow graph should not pass through a node more than once. So what is a forward path gain of forward path 2? G5 into G4. This is a forward path gain of forward path 2. Now we have to find the individual loops. So we have to find the individual loops. So this is your signal flow graph. From this, what is a loop? It has to start from a node and it has to end from after traveling it has to end in the same node. So this is nothing but the first loop. It is starting at this node and it is ending at the same node. So this is the first loop. So its gain is G2 into minus H1. We are taking it as L1, loop 1. So minus G2 into H1 is a gain of loop 1. Next we are going to find the loop 2. So it is starting here, after traveling it is coming to the same node. So what is its gain? G1 into G2 into G3 into G4 into minus H2. So minus G1, G2, G3, G4 into H2. So G1, G2, G3, G4 into H2. So this is nothing but the gain of loop 2. Now we are going to see the next loop. This is the next loop. It is starting at this point. After traveling, it is reaching the starting from here, after traveling, it is reaching to the same node. What is the gain? G5 into G4 into minus H2. This is a loop gain of third individual loop. Okay. Now we are using Mason's gain formula. What is Mason's gain formula? Overall transfer function is equal to delta k, tk delta k divided by delta. So delta is a system determinant to be calculated as, and k is a number of forward path in signal flow graph, and Tk is a forward path gain of kth forward path, and delta is nothing but 1 minus sum of individual loop gains plus sum of gain products of all possible combination of two non-touching loops minus sum of gain products of all possible combination of three non-touching loops, and delta k is nothing but delta for the part of graph which is not touching the kth forward path. Now we are going to calculate delta. First we are going to calculate delta. Delta is nothing but 1 minus sum of the individual loop gains. So this L1, L2, L3 are nothing but the individual loop gains plus sum of the loop gains of two non-touching loop. Okay, so we have to find the two non-touching loops. In our from this diagram we have to calculate the two non-touching loops. So non-touching loops are loops which are having no common nodes. Consider this loop and this loop. So they are having common nodes. So these two are not non-touching. Now you consider this loop and this loop. These two are non-touching. Why? Because these two are not having any common nodes. These two are not having any common nodes. So these two are non-touching loops. Loop L1 and L3 are non-touching loops. So from we have calculated the non-touching loops. The non-touching loops are nothing but L1, L3. Okay, and their gain is nothing but G2 H1, G5 G4 H2. This is nothing but the gain of two non-touching loops. We have substituted here the individual loop gains and the non-touching loops, and we have calculated the value of delta. Okay, then we have to calculate delta 1. Delta 1 is nothing but forward path 1. So in forward path 1, which part is not touching the first forward path? So we have to again go to the. Now this is the first forward path. This is the first forward path, and this loop is also touching the first forward path. This loop is also touching the first forward path, and this loop is also touching the first forward path. If all the paths are not touching the particular forward path, then the value of delta is 1. Okay, so delta 1 is equal to 1. Now we are going to see this is the second forward path. So the second forward path, this G2 H1, this part is not touching the G2 minus H1, this loop part, it is not touching the second forward path. So you can, so delta 2 is nothing but 1 minus the part which is not touching. Which part is not touching? Minus G2 H1 part is not touching. So delta 2 is equal to 1 plus G2 into H1. Now we are going to find the transfer function using Mason's gain formula. What is Mason's gain formula? Delta k into Tk into delta k. So here you are having two forward paths. So T1 delta 1 plus D2 delta 2 plus delta. So we have calculated T1 is nothing but the forward path gain. Delta 1 value is 1. T2 is nothing but the forward path gain of 2, and delta 2 value is nothing but 1 plus G2 H1. So already we have calculated delta. So if you substitute these values, you will be getting the overall transfer function. Okay. So first we have calculated the number of forward paths, then we have calculated the loop gains, then we have calculated the individual two non-touching loops. After that we have calculated delta. Then we have calculated delta 1, then we have calculated delta 2. After that we have substituted everything in the Mason's gain formula, and we have calculated the overall transfer function of the signal flow graph. So very easily by using this Mason gain formula we have found out the overall transfer function.